The surface of Mars is a freezing, irradiated desert. The atmospheric pressure here is less than 1% of what we experience on Earth, creating a near-vacuum environment where average temperatures sit well below -60 degrees Celsius. The danger extends into the soil itself. Rovers have detected high concentrations of perchlorates, highly reactive chemical salts laced throughout the dirt that make the ground toxic to human biology. Looking at this atmospheric breakdown, we see a stark contrast. The Martian atmosphere is 96% carbon dioxide. Unlike Earth's nitrogen and oxygen-rich envelope, this thin layer is unable to trap solar heat. Based on these surface metrics and the current atmospheric chemistry, Mars operates as a dead, hostile rock, incapable of supporting biology. Yet, high-resolution orbital observations reveal deep surface scars that do not belong in a dead desert. This topographical map traces enormous anomalies, occluding outflow channels like Ma'adim Vallis. This single canyon stretches 700 kilometers, carved by ancient moving water. But this creates a contradiction. Because of low atmospheric pressure, liquid water introduced here today would instantly boil into a gas. Despite that, the presence of ancient crater lakes and delta formations prove that liquid water did not just flash flood, it flowed steadily over long periods. Mars lacks the physics to support liquid water, yet the ground is defined by it. The geography and atmosphere tell two completely different stories. 4.5 billion years ago, the environment was unrecognizable. Deep inside the planet, a molten iron core was spinning and churning. This active planetary dynamo generated a strong magnetosphere. This schematic shows magnetic lines wrapping around the planet, creating a shield that deflected incoming solar wind. Safe behind that shield, volcanic gases accumulated. A thick atmosphere built up, stabilizing massive liquid oceans in the northern lowlands. During the Noachian era, Mars possessed the exact physical recipe, the core dynamo, the shield, and the atmosphere necessary to foster an Earth-like environment. That system reached a catastrophic failure 4 billion years ago. The internal dynamo cooled and ceased, shutting down the magnetosphere. Without protection, the atmosphere was defenseless. High-energy solar winds began interacting directly with the air, stripping atoms away and carrying them into deep space. As the atmosphere thinned and the planet cooled, Mars entered the Hesperian period. This transition triggered extreme planet-wide volcanism. The formation of the massive Tharsis bulge was a symptom of this geological overdrive. It physically cracked the planet's crust, carving out the 4,000-kilometer Valles Marineris Canyon. The Noachian oceans could not survive the loss of pressure. The water either boiled off into the void or froze deep within crust. This era serves as proof that losing an invisible magnetic shield can lead to the physical collapse of an entire biosphere. Despite its surface appearance, Mars is dormant rather than dead. The ancient water never entirely left. Radar scans reveal vast deposits of water ice locked in the polar caps and hidden in subsurface glaciers. Seismic data from the InSight lander reveals that the interior still trembles with Marsquakes, showing that internal activities still lingers deep beneath the dust. Mars operates as a frozen planetary time capsule, preserving the remnants of its once living state just under the surface. Mars functions as Earth's planetary control group, a world born with the same ingredients that suffered a vastly divergent fate. Modern robotic missions are currently analyzing these rocks to decode the exact threshold between living and dead worlds. Humanity is now preparing to transition from robotic rovers to crewed missions, utilizing next-generation launch vehicles like the SpaceX Starship. We explore Mars because its history provides a forensic study of planetary survival, holding a mirror to the fragility of our own existence.